Yeah, you are audible and I am starting the recording.
Okay, fine. So before we proceed for today's tutorial, is there any query for yesterday's class? Okay. So if not, then let us start about today's tutorial. So today we are again going to do a hands-on experiment on blockchain and the blockchain smart contract. So today we'll start with one permissionless blockchain architecture, which is Ethereum. So you will learn that how you can create an account over Ethereum, and then how you can create a kind of smart contract on top of Ethereum test network. And then finally, you will learn that how you can create your own smart contract and deploy it over Ethereum blockchain for a decentralized execution of the corresponding smart contract. So the TS, Disha Snigdha, they will be taking care of the tutorial and then subsequently the corresponding assignment that will be given for today. So I'm handing it over to Bishak Snigdha and Vipra. So Bishak, over to you.
Yes, thank you. So I'm starting the screen share. Is it visible?
Yes.
Okay. So today in this tutorial, so we will be covering the basics of Ethereum. Specifically, you will see how to run an Ethereum client and how the Ethereum client syncs blocks and everything, and then how do you actually interact with the Ethereum network. So and we will see what do we exactly mean by Ethereum network and some other test networks that are also available. So here we will be, I mean, in this first part of this tutorial, we will only see how to query smart contracts and execute smart contracts, do transactions, query some other informations from the blockchain and from the blocks. And then in the next part of the tutorial later in the coming weeks, we will see how do you actually write your chain code. So here we will be working on some existing chain codes and see how they work. Okay. So just getting started with Ethereum. So you have already as you have already studied in the previous lectures. So this Ethereum technology is basically a decentralized platform which is capable of running smart contracts apart from the apart from the usual transactions which most other cryptocurrencies also provide. So they pitch it like a technology for digital money, global payments, as well as applications. Okay. So how does this Ethereum network work? So since it is a decentralized or distributed network, there is no central server or anything. For example, that you have in cloud services like Facebook or Google, whatever applications you use online. But instead, in this Ethereum network, you have this network of computers running the same software or the software built on the same specifications of Ethereum, which are known as nodes. And these nodes can be used to verify blocks and whatever transactions are going on. So an application which is known as Ethereum client running on your computer is a node. So anybody who is running this Ethereum client is basically running an Ethereum node, and these Ethereum nodes are connected in a peer-to-peer network. They basically talk to each other directly, and thus Ethereum network works. So basically, in this in each node, you can say that there are these major components. So one is the proof of work consensus. You are carrying out mining as well as for verifying the output of the proof of work consensus. So this consensus module can be replaced by other consensus mechanisms. So Ethereum actually provide three prominent consensus mechanism already. So the main currently the main Ethereum network uses proof of work only. And then there is this module called EVM. This is Ethereum Virtual Machine. So in Ethereum, the smart contracts are actually run on this particular virtual machine. So the smart contract code that you write in languages such as Solidity, they will be compiled against this EVM, and the machine code that is generated from that Solidity compilation is executed in EVM. And apart from the EVM, there are other components like maintaining the Ethereum's ledger state, which has the smart tree also and the blockchains also, and then there is a transaction memory pool which hosts all the recent transactions, etc. And then this entire component, the client interacts with other clients through this peer-to-peer network. Okay. So actually, as I said, there is no centralized server. Instead, several nodes, online nodes, are running this network. So etherscan.io has a map of nodes that contribute to etherscan.io. So you can see that in India, 57 nodes are contributing to etherscan.io. Similarly, all over the world, there are nodes which are online. This is for Ethereum main network. Okay, so how do we actually interact with this Ethereum network? So we have a network which has smart contracts, accounts, then transactions, block data, etc. So this network is accessed by the Ethereum client. Okay, the most prominent client is Go Ethereum. I will come to that shortly. So so a computer or a host running this client is called a node. All right. Then this client is actually using its peer-to-peer connections to other clients to sync all these data for account, smart contracts, etc., which are already there in the network, and get itself updated. So whatever transactions that the client will make or you will make, it goes through this client, and those transactions are basically broadcasted and propagated through this network in a peer-to-peer manner. Okay, then on top of this client, you will be writing your application. So that is provided by JSON RPC API. So this client exposes HTTP endpoints as well as an IPC endpoints, which can be used to build applications with the help of it. So there are some user-friendly libraries like Web3.js, Ethers.js. So those libraries can be used to interact, and using those libraries ultimately for distributed apps or decentralized apps or DApps, you can provide GUI you can develop GUI for interacting with your smart contracts ultimately with the help of these libraries. Okay. So this network maybe looks something like this. So there is no central point. Instead, in this peer-to-peer network, everybody is sharing their information directly with other nodes. Okay, let's learn more about the Ethereum client, which is most popular. So it is called Geth or Geth. So basically Go Ethereum. This is the official implementation of the Ethereum protocol, and this was the first one that they released from the beginning. And this Ethereum client is basically the entry point to any Ethereum network. So it can be mainnet, testnet, or you can host your own private Ethereum network. I mean, which is with the help of some nodes. So you can start a bunch of Go Ethereum clients, and they will start form their own network by initiating a Genesis block and all. So this Go Ethereum client is capable of running as a full node, or full node meaning it will sync all the blocks and validate all the transactions from the beginning, or it can uh, act as an archive node. So yes, for full node it will sync the block headers. For archive node it will retain all transactions, all blocks and everything, and for with this light node mode, it will be retrieving minimal data and just the amount of data which is necessary to get started. So some recent block headers and recent blocks. So uh, and then this Go Ethereum provides JSON RPC endpoints over HTTP, WebSocket, and IPC transport. These are the three interfaces: HTTP, WebSocket, and IPC transport, which you can use to interact with it. Okay, so how do we install it? So there are installation instructions in the documentation page for most platforms. So you can go ahead and find the instructions for the OS you are using and install it. So this here I have just given the instructions for Ubuntu. Okay, then let us see how we can use this Ethereum network to manage accounts, connect to the network, and do some queries, get some information about the network. So for managing accounts, we have this command called get space account, and then for listing commands, listing accounts, we have list new. For creating an account, update and import I will talk about shortly. So let us start. Let me show you how this works. Yes, I hope you can see my terminal. So I have this Go Ethereum client already installed in my computer. So you can see the version like this. So it is version 1.0, and then I can see the accounts that I have. So if we just press account, then it will show you the usage. Let me list. Okay, so it is saying that I have two accounts, account 0 and account 1. So in Ethereum, an account is just a private key and public key pair. So it uses ECDSA encryption to generate and use this and sign this and everything. So this string is the public key, and the private key is not shown in plain text because it is ultimately when you create an account, Go Ethereum encrypts this private key with a password, so it is password protected and not in plain text. Okay, so how do we create a new account? We will simply write gh and then account and new. Okay, so it will ask for a password which is used to lock the private key. Okay, so I can give a password. It won't show up in the terminal, so I'm typing a password. And so it takes some time to create the account because it involves cryptography, so it is a bit slow. So let us give it some time and go through the slides once again. So this is how you create an account, and then I already have shown you this account list will show you the list of the accounts, and there is a path. If you see that there is a path to the key store. The key store is the directory where Go Ethereum is storing your keys and in files, and these files have the keys in an encrypted way. So yes, actually you can view. Let us see if it is generated. Yes, I see that it is complete. Then so Go Ethereum is saying that you can share your public address with anyone and others need it to interact with you. The public address is this one. Okay, and this secret key file is actually storing the private key also, so which we should never share, although it is encrypted with the password, but still we should never share. And the private key, if you have the private key, then that is enough. So from that private key you can easily generate the public key. So if you want to store your account somewhere safe, you can take a piece of paper and write the private key down. Okay, but let us see that if we can see the private key. Let us take the one that we generated. Okay, let me clear this. So this is the contents of the file in the key store. So you see that the address is given. This is the public key, and then there is a object called crypto. Inside the crypto, we have so many things called cipher, cipher text, then cipher params, and then MAC and ID. So, and this version is the version of the key store. Okay, so the key store formats version. So the private key is stored in an encrypted way like this. So the cipher is AES 128, and then this is the cipher text. So if you decrypt this using the cipher parameter, then you will get the private key. So there are instructions on how to do that. If you search in the internet, you will find that. Okay, okay, let's proceed then. So if you start this Go Ethereum without any options, I mean just press Go Ethereum and hit enter, then it connects to the Ethereum main network. Okay, but obviously for if you want to do any transactions in Ethereum, you need to pay some mining fees, which is also called gas in Ethereum. Okay, so these mining fees you need to pay, and therefore doing some transactions in the Ethereum main network will mean that you need to somehow get some Ethereum coins or ethers, right? So how do you get some of those Ethereum? You can do mining, but nowadays obviously mining is very difficult because there is so much mining difficulty and so many miners and mining farms there. So it will take years for you to mine something. So you can buy some Ethereum from the exchanges in exchange of normal currencies and do that, but obviously that will be expensive. So what you can instead do is you can connect this Go Ethereum client to some test network. So this Go Ethereum is already preloaded with the configurations to connect with some popular test network called Rockchain, like Rockchain Ringbee and Go Early. So we will be using Go Early today because this Rockchain and Ringbee is having some problems from last week. Okay, let us try to see what happens if we just start Go Ethereum without any argument. So I started G8H, and then what is the output? So you see that it is saying starting get on Ethereum mainnet, and then it is doing a bunch of things. It is updating the cache, getting PR count, and doing allocating memory, etc., etc. A lot of housekeepings are being done, and then it is initializing the Ethereum protocol from here. So after completing all the housekeeping, and finally you will see that it will be importing block headers. Yes, so you can see that it is ultimately importing some new block headers. Okay, and it will keep on doing that. So it is so at this point it means that it has already connected with some peer-to-peer with some other peers to the P2P network. So you can see that starting P2P node started P2P node, and then it starts importing blocks. So it will keep on importing new block headers and validating them and checking them till it is running. So you cannot actually do anything on this particular terminal. So you cannot give any input to G Ethereum anymore. So in this mode, so there are some modes while connecting to the network. So if you do not provide any options, so I think it starts the full full node mode. So it will basically try to sync all the block headers and validate everything. So it will take some time. So if you have a good internet connection, then it can take from 10 minutes to half an hour or even longer. So let me just stop this one. So instead, to save time, what we can do is start this in some other modes. So what modes are there? So these are called sync modes. So you can start these modes using this option -- sync mode, and then you can pass these options, one of these options. So full is downloading all blocks including header, transactions as well as receipts and generates the state of the blockchain incrementally by executing every block. So you are basically downloading the entire Ethereum blockchain and validating everything from the genesis block till the latest block that we have. Okay, this is essential for mining actually. So if you want to mine something, then you need to start it in full mode. So the other mode is fast. So it downloads all blocks, but it does not verify it transaction by transaction. It only checks the headers. Okay. Then there is snap, which is like this. It will download the block headers, but it has some other optimizations to make it faster. And ultimately, we will be using this light mode, which downloads the block headers only and verifies some of the block headers randomly. So it does not download the transactions or anything. So yes, it downloads the transactions for some blocks. So it chooses some blocks randomly according to some algorithm that they have. You can find it in their documentation that what this light mode is actually doing, and it is just enough to gain some trust that yes, we are connected to the right chain and we have the latest block, that much. So we will be using this light mode. So and also we will be connecting it to a test network. So the name of the test network can be given in this way, -- then the name of the network. So we have these three, as I said. So we will be using this one, Goerli. Let's see. Okay, so I have given this option to connect to this Goerli test network, and then I have the sync mode light, and then this additional option called HTTP. So I will just explain this bit. So let me start it. So I can see that it is starting gate on Goerli testnet. Okay, great. So actually this also has a website, a web portal, which is, I mean, apart from Etherscan, so there is another web portal. So here you can find what is going on in the network. So this portal is actually maintained by some Go Ethereum nodes only. So this is an application built on top of G8. So if you want to build an application like this, you can easily do that with G8. So this is being run by some node which is hosted at this address and nothing else. So just a dashboard. So you can see that the average block time, the time after last block, and also the different transactions that are going on, and the gas price and gas limits, etc. So if there are new nodes, then that also. Okay, we can see that these are the number of blocks that are currently there. So we will see that how do we get these information from Go Ethereum. So you can also build a dashboard like this easily. Okay. So what about this option HTTP? So this is how you interact with Go Ethereum client. So there are actually three interfaces, but we are only interested on with this HTTP over, I mean, RPC over HTTP. So this is called JSON RPC. So the other method is an JavaScript console over IPC. So it creates an IPC interface. So in Linux it is a file, obviously. So using which the JavaScript console can interact with Go Ethereum, but we will be focusing on the second one. So this RPC allows remote applications to access your node, but it has limitations and security considerations because RPC, you can understand, these are remote procedure calls. So if you run your node in your host computer and if your network is open, then other hosts can try to execute something with your Go Ethereum client. So in that way, they are saying that it has security considerations, but IPC is obviously limited to your own hosts and not in the network. But we will be using RPC because it is more user friendly. Okay. So how do you do that? So you remember I already started that client with this HTTP option. So when you do that, you will see that there will be an output like this. So I can see that it says HTTP server started, endpoint is 127.0.0.1, which is the loopback address, and then there is this port 8545. So I can use this IP and port to actually connect with this client which is running and do some operations. So let me start doing that. So in the slide also there are some examples which are given. What you need to do to make an RPC call is just send a post request to the endpoint, just as I showed you. This is the default endpoint, and this post request will have some JSON payload. Okay, so this JSON payload will always contain JSON RPC version number, and then there will be a method name. So according to this method name, the parameters or the format of the parameters will change. Okay, so this is one sample payload which is for getting some accounts balance from in that network. So if you are connected to a test network, then obviously it will get the balance of the account in that particular test network. Okay, so let me try that in the terminal. So you can make a post request with many tools. So there are popular tools called Postman, etc. But in Linux we already have this nice tool called curl. Okay, so normally how we use curl is basically if you don't provide any options and anything, then it can get some do a get request and like get some web page for you. So if you do this, then you can see that it just sends a get request to this URL and prints the output here. So instead we need to do a post request. So for doing post request with curl, we have some options. So -x post, and then where we'll be doing the post request. So it will be HTTP loopback address. So let me just do a line break here so that I can write it easily. So I will pass a header to specify the content type. Okay. So my content type will be application/JSON because we will be posting some JSON data, right? And then ultimately we have to provide the data. So we need to provide JSON RPC version. So it will be 2.0, and then method. So let us do Ethereum balance only. So ETH underscore get balance. It is also provided in the slide, so don't worry. And then parameters. Okay. So the params will be only one address. Let me copy the address. And we will say latest, so it will it will try to query the latest so we will be getting the latest balance for this account, which is specified by this public key. So let us hit enter and see what happens. It has given some error. Okay, it looks like I have made some error in the payload. Okay. I try to copy this payload. Much easier. No. Okay, yes. So we can see that we got a result, and in the result you will also get a JSON obviously. Then in the JSON this field will always be there, JSON RPC version. Okay, so this is 2.0, and then the result is in actually a text string. Oh, sorry, one more. Yes, so this hex string should actually represent the balance of the account, as you can understand, but you have to convert it to decimal. So you can do that by manually calculating or running any program. So in bash actually you can directly do that like this. So if you do echo then dollar, it will give two bases, and this is hex means base 16. So if you give base 16 and then pass this after the hash, pass this value, so you will get the output. So this output is actually the balance of this particular account. Now this is not in the Ethereum unit, so this is not ETH, but this is actually the unit is called WEI, WEI. So one WEI is actually 10 to the power 18 Ethereum. So if you count the zeros, or let me just do it in Python. So if you 10 to the power 18, sorry, yes. So if we divide it by 10 to the power 18, then we see that it is 1. So 1 Ethereum is 10 to the power 18 WEI. Okay. So actually this is 1 point this many zeros WEI. So you can imagine a decimal after 18 places. Okay. So this is the balance of the account. Okay, let us proceed. So let us see some other examples. So in the slide also we have given a sample output. So in this case you can see that in this result we get this hex string which corresponds to this in decimal. So after 18 places you can imagine a decimal, and then so this balance is actually 18.64 Ethereums. Okay. All right. So let us see another command which is querying accounts. Yes, also this is also very small, and so just paste it here. Remember that when you are doing these queries using CURL or whatever HTTP client you are using, the Go Ethereum client should be running. So all along I have not closed this one. Okay, so this one is still running. So you cannot do anything in this terminal. You have to do all the interactions through this RPC. So if you execute this one, so you can see the method is ETH underscore accounts. It lists all the accounts that are associated with this client currently. So you remember that we saw there were two accounts, but it is showing that there is one account here. That is because, so if I create another terminal, that is, I can see something. That is because if we do go Ethereum, then account list, it will show me two accounts, but this is for the main network. If you want to list these accounts for test network, we have to pass this option. Okay, so yes, the name of the test network and then account, then list. So it says that failed because already used by another process. So I have to actually stop this one and then try. Okay, so it shows me that yes, there is only one account. Let me try to add a new account. So it will take a bit of time. Yes, done. So let us start the client. Okay, let us list first. List. Now you see account 0 and account 1. Now you start the client. It will take some time to start. Plus synchronization started. Okay, it has started. So yes, doing that query again, it is accounts. Now you see that we have two accounts. This one, the old one that we already had, and the one we created just now. So similarly, like this, there are many other methods which you can use. So you can find those methods. I have given a link in the slide. You can go through that and get to know all those methods. Okay, but these are just querying, okay, and not doing any transaction. So whatever queries we did till now do not require any gas or any mining fees, because we are just querying some data which is already there in this test network blockchain. But we also want to execute execute some transactions. For example, at least sending some ethers from one network to another network, so sending some currencies. So for that we have RPC calls like this, ETH underscore send transaction, and then in the parameters you need to provide from, to, and this value that you want to send. So let us try this one. So let me check which account I can use. 1 second. Okay, I think I can use this account. So let me just check the balance of the account which I will be using, so that we can send enough. Okay, this is the result. We have enough that I can see. Alright, let us copy this URL. So this will be sending some, this is trying to send some amount from this network 8AF and to this network. So if we execute this, let us see if it will work or not. So it says authentication needed, password or unlock. So actually directly using RPC you cannot do this transaction, because you need to specify which account you want to use to make this transaction, as well as authenticate that. So because you know that the account is password protected in Go Ethereum. So for that, for at least testing purposes, what you can do is you can unlock your account using this method called, using these options called allow, insecure, unlock, and then you will pass the option to unlock this account, whichever account you want to use, and the password you have to provide the password in a password.txt file. Okay. So let us do that. So I already have my password stored in this pwd.txt file, and the account I want to unlock is this one, because I will be using this account to send some Ethereum from here to some other account. Okay. Okay.
Sir,
Let me choose.
that has to be the private key, right? Because if it is public key, then anyone will be able to.
See this password.txt file. Which one is private key, you mean?
Sir, that the key that you are showing before the password.
This is public key. This is
Okay.
selecting the account we want to use. So remember, we have two accounts. So we want to select the account we want to use. Okay. This is the public key. That is why I am showing, and the private key is inside this password.txt file. Actually, the password.txt file does not have the private key. The private key is in the key store. So if you check the default key store, then you will find the private key here, and the private key is not in plain text. So if you copy this thing, then also you will have a hard time to decrypt the private key from here, because it is AES encrypted. Okay. So what this command is doing is reading the password from this pwd.txt, then reading this file, and then using the password obtained from here to actually decrypt the ciphertext. So this decrypting the ciphertext is providing the private key, and that private key will be used to unlock the account denoted by this public key. Okay.
Okay, sir. Understood.
Yes. So this is just selecting the account, and this is providing the password which you gave, during creation of that account in Ethereum client. All right. So if we execute this, okay, it is running already here. This terminal only. Great. So it will also say that we are unlocking some account. Okay, HTTP started, IPC started. Unlocked account. Address this. So this means that you have successfully unlocked the account. Alright. Then after unlocking the account, you can use this JSON RPC to do any transactions from this particular account, provided that it has enough balance. Alright. So let us try to do a transaction. So let me see if I have an account with okay. So we will be sending some Ethereum from this account and sending it to this particular account. So the value we want to send is in hex. So we want to ensure that this value is also correct. Okay. So I hope this is one Ethereum. Yes, this is one Ethereum. So I am sending from this account to that account value 1 Ethereum. Okay. Let us see if it works. Yes, great. So we got some result. Then what is this result? So actually this result is a transaction ID. So I can show you that here. So if we paste it in etherscan, quell.etherscan, and paste the transaction here, we can see that this is a testnet transaction, this is a transaction hash that I pasted, and what is it doing? It is from this account to this account is sending 1 ether. Alright, and the transaction status is indexed in this transaction has been included and will be reflected in a short while. Looks like it is not mined. What will be the status after it is mined? Let me bring up some other random transaction. Okay, there it should say that it is successful. Okay. Let me see my balance if it got reflected here or not. Yes, it got mined already. So you can see the balance is 2 ether. Actually, it was 1 ether a while back. So, but the transaction is not confirmed. So it will take some time to for it to get confirmed. Okay. Oh, it got confirmed right now. Great. So I can see here. Yes. So 1 minute ago, from this account to this account, 1 ether, and this was the transaction fee. Alright, so in this way you can do transactions, but obviously before doing a transaction you need some balance in your account. So how do you get that balance? So these test networks have a mechanism called faucet. So Goel test network has its own faucet, which is this one. So here, how would you get some Ethereum into your Goel account? It is very simple. You need to post your public key, including this 0x part. So you post whatever your public key is. For me, it was this. So you will take this public key and post it in a social network. For example, Twitter works best. So you tweet one, you create one tweet with this public key, post the URL of this tweet here, and then select any of the options. So from one account you can get 6 ethers per day, or 15 ethers per 3 days, or 37.5 ethers per 9 days. So anyone you choose. So you can create one primary account, get some ethers and send it to your other accounts if you need multiple accounts. So you can distribute in that way also. So this link is also provided in the slide. Okay. So as I showed you already, in Etherscan you can observe the transaction. So Ethereum send transaction has other parameters also. So ETH_send transaction can have from, which we used just now, to, and these both we used, and then we used this value. So from, to, and value means sending some Ethereum to the to address. From this from address to address, and then you can specify the gas quantity, which is the limit for the transaction fees. Basically, you can search and learn more about gas prices. So this gas multiplied by gas price will actually determine how much transaction fee you need to spend for this particular transaction. So you can put how much gas you want to spend in this gas limit and also set the gas price. If you don't set them, Ethereum will calculate them with some default parameters. Okay. Then apart from that, this is very important. So we have another field called data. So in this data field, you can actually provide compiled smart contract, or if you want to compile smart contract, if you want to deploy a new smart contract. Okay, so you write your smart contract code, compile that, and then put it in the data field. That will create a new contract. In that case, the to field is not required. So optional when creating new contract, you can see that. And otherwise, if you are not creating a new contract, you can also use this data field to invoke other smart contracts. So you can pass parameters and everything. Then yes, what it returns the result. So you already saw that, a sample of that result. Okay, so in this way you can make post requests manually to do transactions. So apart from that, obviously we want to write some programs to make it easier. You can also write programs to do those post requests and yourself and write applications. So build applications, but this library web3.js makes it much easier. Okay. So this is a JavaScript API which can work with HTTP, IPC or WebSocket, all the three interfaces. The same set of APIs over all the three interfaces basically. So it is like an abstraction on top of those. Using this Web3 API, let us see how we can build some small applications to do some queries or execute some smart contracts as well. So how do you install it? You can just open up a terminal and write npm. If you obviously must have Node installed. So I have Node version 1.3 and also npm installed. So this is the npm version I have installed. If you don't have this, then go to the Node website and npm website and install those. All right. Then I have to do npm install web3. So this will install the web3 library. Okay, now we are basically ready to use this web3 library. So let us see how do we do that. Okay, I can just open a console here, Node. Okay. So I have just typed Node. So this is the Node interactive console, and you can paste your codes directly here. So instead of creating a file and executing that for small piece of code, you can do this. So remember, all this time this client is running, okay, and running with HTTP allowed and also this account unlocked. So this account unlock is required for sending transaction. Otherwise, with Web3 also everything will work, which does not require you to spend some gas with your own account or spend some Ethereum with your own account. So let us import this. Yes, so Web3 is imported. You can see that there are a bunch of functions that you can use from this module. There are a bunch of utility functions also that you might want to use, and apart from that there is a unit map which I found interesting. So you can see that no ether is 0. So this unit, I don't know, basically this has no meaning. Way is 1. So this is the base unit, and everything is calculated with how many ways it has. So if you see ether, then this is 10 to the power 18 way. Okay. So these are 18 zeros. So these are the different units that they call. This is also very popular, GUI or G-way or GUI. So it can be small or caps, both are accepted. Okay, so let us try to connect it to the core Ethereum. So this address, okay, let me do 127 so that you don't get confused. Localhost and loopback is same anyway. Okay, so this is basically connecting to Go Ethereum, and then we can use this API to get the balance of the accounts. So I am checking the balance for this account. Okay. Same line. Yes. So we can see that this is the balance that we got. It is 34 Ethereum. So these are 18 digits here, and this is 34 Ethereum. So this output is always in way. Now you can see that the difference is that in the RPC calls, the raw RPC calls, we were getting the output as a hex string, but instead this library is giving us an integer. Okay. So similarly we can do other transactions. So this is okay, this is sending some amount from this account to that account. Let me write it in a file and execute that. Okay. So this is the transaction object that you need to prepare. This is very similar to the RPC options that we were giving from, to, and value, you can put other populate other fields also. If you are executing a smart contract or doing something like that, you can make other fields, but for those there are utility functions which make that process easier. So send this particular function called send transaction, or this method called send transaction, is only relevant for sending some Ethereum from one account to other accounts. Okay. So saving this now, node. Okay, it says module not found. Which module? Web3 not found. Okay. I did not specify global. Let me specify so that it works from other folders also.
Sir, can we also use Web3 Pi for executing?
So
using this?
Web3 JS is the most maintained one. Web3 Pi is a bit, so it has some bugs and you might be having problems. So if you know Python, then I don't think JavaScript will be any problem. Okay. And for the actual assignments that you will be having, I would recommend, so this week you don't need to submit any code. You will you need to only write some code and do some transactions. Okay, so you can do those in Python. No problem with that. But I recommend using Web3.js because it is more maintained and more stable.
Okay. Thank you.
Okay, let us try. Oh, sample this is not here. Okay. Let me do it from another place. Okay, so this is the same code from, to, and value. Okay. Let us run this. Okay, so we are getting this output by printing the results of the promise. So we can see that we get a block hash, then from address, gas price, cumulative gas used. So this is this object is actually a transaction receipt. Okay, so and you can identify this object using this transaction hash. So if you again go to the website, Etherscan. So you can see that if it got reflected or not. Yes, it is success. Okay. So how much amount did I send? Okay, again 1 Ether. Yes, I saw that already, right? So this code is also working. Finally, the final task final thing that we are going to learn today is about smart contracts. So how do we invoke a smart contract? So yeah.
Just before that, let us check that whether there is any query or any question from the students. So any question from all of you? So this was just a kind of demonstration, and I guess that things will be much more clear to you as you do it yourself after installing the JIT client and then trying all these things on top of that. One of the basic assumption that we are making that you are familiar with programming and these basic tools that we are using.
Yeah, also I think once Vishak is done with his presentation and you are going to do it yourself, we'll stop the recording and save it so that immediately also it will be available to you in case you want to refer back. Vishak, I think it will take another 10 minutes or so for you to complete, or around that time.
Yes, so it will take a few minutes more.
Okay,
10 minutes.
so you please carry on. After that, we'll save the recording, okay, and then start the
Yes.
recording again, but it will be available. Okay, please carry
Yes.
on.
Okay. So yes, so now finally we want to also interact with smart contracts. So this is, I mean, invoking smart contracts or querying smart contracts using the raw RPC, JSON RPC is difficult. You can try that. You have to convert your smart contract into machine code, that EVM code, and post that. So instead, I'm just showing you how to interact with smart contracts through the Web3 library. Okay. So this is an example contract where you can see. So this is actually identifying which compiler versions should be used to compile this contract. And so this code is in Solidity language. Okay. So this is the name of the contract, a simple contract which will take an unsigned int 256 number, and then it defines two functions. One is store and the second one is retrieve. So retrieve is actually a query. So you can see that this function then retrieve, which does not take any argument, is marked as public view. Okay. So public view means no transaction fees or anything is required, and anybody can query this or call this method, and then it returns this particular the same type, and it is returning the number. Okay. So this is query, and this is the actual function that you need to invoke. So this is for storing. So it takes a number and then it stores here. So this is as simple as it gets. So let us see how do we interact with this smart contract. So for invoking any contract, we need two things. First of all, the address of the deployed contract. So we will be using this one. Let us see if we can view this in search scan also. So it says that yes, it is a contract in this address. It had two transactions. Can we see the contract? No. So we can only see the bytecode, and I mean the machine code, which will be the bytecode which runs on EVM, and not the actual contract. So for executing the contract, you need this address as well as the methods you want to execute. So that is important. And not only the methods, you need the ABI. So ABI is application binary interface, because see, in the Ethereum blockchain, this contract is deployed as a bytecode. So we don't know, we can't see from this bytecode from which location one procedure call is starting, or one function is starting, and in which location the storage, I mean the integer will be stored, right? So we need this ABI to get those. So I will show you how you can get that. So this can be generated in two ways. One is using the Solidity compiler. So Sol, this is the default or the popular compiler of Solidity. So you can use this using this command, sol space file name or of your code. So the code is this one. So you can save this code in a file, and you can execute this command to get the ABI. Or the other way around is there is this popular editor called Remix, which works in your browser. Okay. So if you open this Remix editor, let us create a file. Sample.solve. So I have to paste this code and click save. So as soon as you save it, it will be compiling it in this tab, Solidity compilation successful. So here you can find the ABI. Okay, if you click this ABI, it will be copied to your clipboard, and you can open your text editor of your choice and paste it. Yes. So this is like a JSON, not like a JSON. This is a JSON. So you can see that there are some, so this contains some information about the contract, namely this is one function and this is another function, and the name of this function is retrieve, the name of this one is store. So this inputs nothing, so the input is empty, but outputs the type this, and it also has some other information. So depending on the complexity of the contract, this can be very large. So you need to provide this, you need this to execute it actually, because your Web3.js library will get to know the name of these functions and also the order of these functions which are defined, so that it can use it to invoke the contract which is already deployed in Ethereum ledger. Okay, so let us go back to the slide. Now this is a sample code of how to execute the contract. So here we will be executing that get, the retrieve and store contract only. So you need to import Web3 and then also import this contract object from here. Okay, and set the provider to your Go Ethereum client. So you can do that by specifying new Web3 providers, HTTP provider. We are using the JSON RPC over HTTP, and then this URL. So it can be 127.0.0.1 also, the localhost, and that is same. Okay. Now you have to initialize the contract. So you can do that by saying new contract, and then you have to paste your ABI here. Okay, so this ABI is a JSON. You can read it from a file also, no problem. And then you have to provide the address of the contract which is deployed in the network. So I hope this address is matching. Check. Yes, FB7985. Yes, so this is the store retrieve contract that I just showed you. And finally, this argument from and containing from and gas price are some optional parameters that you can set. So from, if you specify from address, this is the address of your Ethereum account that will be used by default in order to execute these contracts. Okay. And the gas price is we will specify what gas price you want to use. So this block will be creating the contract object, and then it will be assigned to my contract variable. So you can execute your contract methods as follows. So my contract dot methods, then dot. So this, instead of store, you will, this is basically your function name. All right. So any function that you have in your Solidity code, here it is stored. You have to write it here and then give the arguments. All right, and then hit send. So here so here I have this code. So I have pasted this ABI here already. You can see. retrieve, store. Yes, this is the correct API. This is the address of the contract, and this is from cash price. So instead of store, I am going to call retrieve. Okay, my contract dot methods dot retrieve dot call. Yes, there is also one difference between a contract which is a public view and a contract which you need to invoke. So if you give store here, so the store takes some argument, a number, then you need to write send. Okay, because it will be changing the state. But if you query a public view like retrieve, which does not take any argument also, then you can just specify call. It won't require any ether to execute it. Okay, let us save this and run this. Yes, I can see that it says 66. So this is the value that was there already. Let us try to store also. Store 19 and hit send. So obviously, if you are sending something, then it will take some more time because it is executing a transaction which must be mined. Yes, we got this. Okay, now let us again change it to retrieve and call and run it. It says 19. Okay. So how do you know that it is getting affected in the blockchain also? You can always go to this block explorer and find out more about this transaction. So this transaction has been mined in Goel network. The block is this. So this from address is your account and the to address is your smart contract address. Yes, this is also important. I forgot to mention. Whenever a smart contract is deployed in the blockchain, then that smart contract also gets its own address. Okay, so this is the address of the smart contract, and so I won't be able to see the parameters in raw format, but I can see that this is the method ID and it got one argument. Okay. Yes, so the argument is 19. So you can see that yes, our contract, I mean the execution was successful. I have provided some screenshots here. Yes. So the samples, codes and everything are provided in these slides, and there are some important links in these references. Primarily, you can find the reference of this JSON RPC calls here. So you have all the different methods that are available, and the Web3.js documentation link is also provided. Okay, that is it. And if you have any questions, then let me know. Otherwise, I will move to the assignment part. So do you want to stop recording or?
Yeah. Let me do that. Okay. Let me stop the recording and start again. Okay. Just give me a moment. I'm stopping the recording.
Okay.